All right, Module 3.6, scene structure with these polynomials. So go ahead and turn to page 30 in your packet, and we're going to start on questions 1 through 3, and then we're going to talk about questions 4 through 6. So as you guys are turning there, I'm just going to ramble on a little bit about process, procedure, a special case when it comes to factoring this type of scenario. So whenever we have this is called the difference of two squares pattern. So whenever I have something, let's say it's like x squared and minus 16, if I have subtraction between two perfect squares, to factor them, I just take the square root of the first and the square root of the last term, square root of the first, square root of the last term, and then we have one is positive, one is negative. Now these aren't opposites per se, because notice that the x term of this factor is positive and the x term over here is also positive. So they're not opposites, but instead they're called conjugates. So I'll write that down. Conjugates. Okay? And conjugates are going to be important a little bit later, but conjugates look exactly the same, but the sign that's in between them are opposites. Okay? So it doesn't matter if it's just a single term, whatever it is. So we could say a squared minus b squared, or we could say weird looking shape squared and another weird looking shape that's different somehow squared minus. So this could have more than one term, kind of like on question number 1. So I want you guys to try to factor number 1, 2, and 3 real quick. Alright, so question number 1, if you guys did that, we see that we could take the square root of 4 and the square root of 25. And so the answer is 2x plus 5 and 2x minus 5. So make sure that they're right next to each other because they're multiplying together. And then also, it doesn't matter if you put the minus first and then the plus and the second factor. They will both multiply and get the same thing. So if you did number 2, we know that the square root of 9 is 3 and the square root of 16. Just make sure that you put y in both the first and the second. Okay, that's how they get the y squared there. And then for the last one, we have something squared and something else squared and the third thing squared, so same scenario here. Okay, now looking at this one, we have a cube. Okay, so this is not like this one, and the biggest mistake that someone's going to look at here is say, okay, well this is cubed and I know 125 is cubed and 64 is cubed, so maybe this is just going to be something like, well maybe it's going to be 4x minus 5 to the third power. Or someone's going to say, well, 4x minus 5 times 4x plus 5. But since it's like to the third power cubed, maybe I got to throw in another one, and maybe I just got to put a 4x minus 5. Now these are the most common mistakes that I see for questions number 4, 5, and 6. Do not do this. In fact, I'm going to put this on the test where I will make this answer choice A and answer choice B, because I know that you guys you'll just fall into that trap, okay, unless you're listening to me right now. So if I'm going to erase that. If you guys flip back a couple pages in your packet and we go to our homework from 3.4, 3.4 starts you off and it says, okay, go ahead and multiply this. So you're going to multiply this and you end up with this. Okay, great. And then it says multiply this. Now you got a binomial times a trinomial. When you multiply this, something happens with some of the middle terms and you're just left with something right here and something right here and minus. And then you do it again and now you get plus. And then you do it again, you get over here, you get minus, and then this one, this one. So notice what's happening here. This looks a lot like the problem that we have on question number 4. So we have something cubed minus something else cubed. Notice that the factors look like this. So let's try to analyze this. I see, well, what was cubed to get x cubed? X. What was cubed to get 125? Well, 5. Okay, so that kind of makes sense. Now x, okay, so they just took this thing and squared it. And then I see 25, so 25 is 5 squared. And then how did they get the middle term? Well, that's why we look at question number 28, because it says for any numbers, okay, any numbers that if you were to multiply them together, notice what we get. If you take the cube root of that first term, the cube root of the second term, square the first, square the last, and then for the middle term, you just take this term and multiply it together. Okay? Now, another way that I like to think about it is how do I get something to the third power? Well, something can to the third power, like it could be from taking something that's to the first power and multiplying it times something to the second power. So notice that these are all to the power of 1, and then over here we have squared. Okay, so let's go back and see if we can try to apply something like this to what we just did a second ago. So, all right, with my formula and looking back at 3.4, I'm going to try to do question number 4. So what was cubed to get 64? Well, this is the same thing as 4 to the third power. So 4 goes right here, and also the x. And then what was cubed to get 125? Well, 5. Okay, now over here, I'm not going to do the signs yet. Just wait. Over here, I'm going to square the first term, which would be 16x squared. Square the last term, which is 25. And then the middle term, like we saw in our 3-4 homework, is just the product of these two terms. So 4 times 5, that'll be 20, and don't forget about the x. Okay? Now, the last thing to do to clean it up is we're going to use SOAP. And I'll show you how this works. The S stands for whatever this sign is, it's going to be the same. So same, and then opposite sign, and then the last one is always positive. Okay, so same, opposite, always positive. Okay, so if we go back, not there, but if we go back to what we have here, let's see if that pattern continues. So if this is positive, same, opposite, always positive. If this is negative, so same, opposite, always positive. So now that's a really interesting point here, because over here, for the first 3 questions, it has to be subtraction. It doesn't work if it's addition. So when it comes to the difference and sum of cubes, it doesn't matter. Obviously, it could be minus or it could be plus. So keep that in mind, and I want you guys to try number 5 and number 6 right now. All right, so we know there's going to be a binomial multiplied times a trinomial. What was cubed to get 27? 3, and the x. And then what was cubed to get 8? That'd be 2. Square the first, square the last, multiply them together to get 6x. And then use SOAP to clean it up. Same, opposite, always positive. All right, last one here, question number 6. What was squared to get, cubed to get 1,000? That would be 10. And then we have x, and then we have y. Square the first, square the last, and then multiply them together. And then use SOAP. Use SOAP to clean it up. Here we go. So same, opposite, always positive. So the moral of the story is to always know your cubes. So not just your Rubik's Cube, of course, but your perfect cubes. So looking at these numbers right here, if you see them come up, that means that we could probably factor it using this knowledge of difference of cubes. So take a look at this. So same, opposite, always positive. If you didn't get it down the first time, so this is the original problem that we're trying to factor. So the signs work as this. So whatever sign is initially right here, that's going to be the same sign that goes right there. And then we take the opposite for this one, and then this last term will always be positive. Okay, so a couple of examples right here. So this is a x cubed minus 125. We know that x was cubed and 5 was cubed for that. And then we square the first, and then we square the last and multiply them together. And then notice the signs. So same, opposite, always positive. I think you guys got it, but I want you to understand how this could benefit you when it comes to a test. So take a look at this test question right here. We see that it says to factor, and we have all these choices. Now, knowing the little SOAP right here, this guy, then we know that our first factor should be positive. So we can eliminate B and C and know that it's got to be one of these. Okay, and then same, and then the second right here should be, well, this isn't even right? So it should be negative, so D has to be the answer choice. Okay, now I'm not obviously going to give you something that easy, but you might see it on another teacher that, isn't so crazy. So you guys get it? Good, that's going to be very useful in the future. So let's continue and start our lesson. So 3.6, scene structure. Basically what we're going to do is just practice a couple polynomials, make sure that we, anything and everything that we know about them, we're going to just write it down. So you should have this piece of paper in front of you. It says page 28. We're not really going to read this too much. We're going to cut right to the point here. Okay, so this is what I want you guys to do. Right now we're looking at this polynomial that we see, and we're trying to get everything and all the information possible. So what do we know about this thing? Well, first off, it's in factored form. Okay, it's in factored form. We know that if this was to multiply out, this would be a degree of 3. And then we see that there's a minus in front, so we've got a negative power of 3. So if we have a negative power of 3, is that going to be a touchdown or a disco? Well, it's going to be a disco because it's odd. And then since it's negative, it's going to be headed down in this direction. So it's going to be decreasing from left to right. Okay, so that's going to help us out when it comes to our end behavior. As we approach to the left, remember this means left. As we go to the left, the function is going to be increasing. And as we go to the right, that's what this one is saying, as x approaches positive infinity, we will be decreasing. So we have our end behavior. We know our leading term. Okay, now let's talk about maybe some intercepts. What are the x-intercepts? Well, looking up here, we see that this has an x on the outside. So if we set that equal to 0, negative x equals 0, that would just be 0. 0 is one of our x-intercepts. And then over here, if we set this equal to 0, that'll be positive 2. And that last one would be positive 4. So these are our x-intercepts. Now what would be our y-intercepts? Well, initially we would look at our last terms and just multiply them together and maybe say 8. But since we have a negative x on the outside, that's going to make it a negative 8x. Since that's not a constant, so our y-intercept, as we can see from our x-intercept, is also going to be at 0. So let's draw up a coordinate plane off to the right. And let's put this information, as much information as possible, down, and let's just see what this thing is going to look like. So we have 0 as an x-intercept. We have 2 as an x-intercept, and then we have 4 as an x-intercept. And then since we know that our end behavior is going to be coming up like this, and this one right here is going to be coming down like that, we already got at least half of our graph situated. Now we know that there's no bounces, there's no multiplicity, so it's not going to be bouncing off the x-axis. So this is going to come down and then go up and then come around. So I'm just going to do a makeshift real quick, just like this. And we're going to talk about this because these points right here, this would be a relative minimum and this would be a relative maximum. I want to talk on how we would actually find this. So it's not always like exactly in the middle like it is for a parabola, but if we were to kind of split the difference between these x-intercepts, from 0 to 2 would be 1. So if we were to substitute into this equation 1 in place of our x, so this would be 1, this would be a 1, and this would be a 1. Let's simplify. So this would be negative 1 times, that's that one, and then 1 minus 2, that'd be negative 1, and then 1 minus 4 would be times negative 3. So that would become a positive 1, and then times the negative 3 would be negative 3. So this actually hits down at negative 3. Okay? So see, I mean, if we want to be accurate, and we will eventually, I've been telling you guys that it doesn't really matter, but now it's starting to matter, okay? So we want to know where that minimum, that relative minimum is going to be. And so it doesn't take that much. We're just splitting the difference between the x-intercepts and then going from there. So I erased it. So 1, 2, 3 comes down here, and so we know that this guy is going to kind of loop around. I'm going to use blue. Is going to loop around, come like this, and then come back up to that point. Now we could do the same thing over here. So this is 2 and this is 4. So if we substitute in 3, let's see what that does. Let me erase that too. So if this is a 3 and this is a 3, 3 and this is a 3. So on the outside that'd be negative 3 times, that would be 1, and then that would be times negative 1. So that would simplify to be 3. So let's get this cleaned up. And so here it'd be 1, 2, 3. All right, so then this point comes up, wraps around. All right, not too bad. I want you guys to try to do question number 3. So you're figuring out what form it's in, x-intercepts, y-intercepts, end behavior, and then go for the graph. All right, So I'm just going to put some of this stuff on the paper here. Okay, over here. Question number 3, we see that it's in factored form because it has parentheses. So we can tell that if we were to multiply, that'd be a degree of 3. We know that it's going to be a disco, and it's going to be a positive disco. Our x-intercepts, well, we're going to have to factor. So when we factor this, we find factors of 4 that give us 4 or 2. We have multiplicity, so that means it's going to bounce off the x-intercept at -2. So 0 and -2 with a bounce on -2. Since it's a disco, we can also tell our end behavior is at negative infinity in the negative direction, and then positive infinity in the positive direction. And we have a y-intercept at 0. So when we go to graph this, we're going to have an x-intercept here, x-intercept there, but a bounce on the -2. So check and see if you guys did that. So we've got at -2, it's going to come up, bounce off the x-axis, and then come back down and wrap around. So my minimum value right here, that was a little bit past 1. So if you substitute in one of those values, probably if you substitute in 1, if you put a point right here, that's okay. But notice that it's a little bit closer to the 0. It's not exactly in the middle. Okay? All right. So I think it's on the back side. So flip it over, and I want you guys to try 4, 5, and 6. And then work together with your partners, and we'll run through this in a second. So question number 4, this is not in factored form, this is in standard form. So we can see though that it's a degree of 3, and then we have a y-intercept since it's in standard form of 0, so we know that. And it's going to be a disco because it's a degree of 3, and it's going to be a positive disco, so we know our end behavior. Let's talk about factored form, what that would look like. Well, if we pulled out an x squared, we'd be left with x minus 1. And so this will help us find our zeros or our x-intercepts. So our x-intercepts are going to be at 0, and then also at positive 1, and our y-intercept will also be at 0. And then since it's a disco and it's going in the positive direction, and the negative direction, in the negative infinity, as we approach that way, it's going to be going down, and then as we go to positive infinity, it's also going to be going up now. Okay, so now when we go to the graph, we're going to have a bounce off 0. Notice that we have an x squared right here. So there's going to be a bounce on 0, bounce off of 0, and then we have a y-intercept. Now, if you put in 1/2, you would have gotten a really tiny number. So just know that it doesn't. It just kind of loops down, and that's roughly should be what your graph looks like. Okay, question number 5. We have a quartic type function. It's a degree of 4. So since it's a degree of 4, we know that it's going to be a touchdown. And we already have our y-intercept at -16, so that's good. When you factor something like this, what I did here is I looked at this and I said, okay, this is almost like the difference of 2 squares pattern, but in order for me to use it as the difference of 2 squares pattern, I had to look at that x to the 4th and say, man, is there a way that I could write that as something squared? Because if that was something squared and then I had the 16, which is 4 squared, then this would work. So in order for that to happen, this would be an x squared. X squared squared would be x to the 4th. And so now what we do, before we get to this stage, is we would then say, okay, x squared minus 4, and then x squared plus 4. So this would be the 2 factors. Remember, these are the conjugates. And then since this has subtraction, we could then factor that even further as x plus 2 and x minus 2. And notice this x plus 4 is still there. All right, so since we have those, coming up with the solutions is going to be a little bit tricky for this one, but we'll be able to do this. So we'll have -2 and +2, and then if we set this equal to 0 and solve, we end up with imaginary solutions. Okay, so the only real solutions are -2 and +2. Our y-intercept is at -16, and since it's a touchdown and it's positive touchdown, that's going to be going towards positive infinity for both of our behaviors. So when we put this on the graph, just make sure that you go all the way down and you pass through -16 and -2 and 2, and I think you'd be pretty good. All right, last one. So here we have not factored form, but standard form. We could tell because there's no parentheses. It's a degree of 3. And since it's a degree of 3, we know that it's going to be a disco. And it's a positive disco. That's going to help us out with our end behavior. But let's see, is there a way that we could factor this to help us out with our intercepts? Well, I see that there's a common factor of x, so we could pull out an x. Let me write that down. So if we pulled out an x, then we'd be left with x squared minus 2x minus 3. And then we could factor what's inside the parentheses here. So what are factors of 3? That would give us 2. Now, or negative 2, excuse me. That'd be negative 3 and positive 1. So that's factored form, and then from there we can come up with our intercepts. Notice that this x is on the outside. You guys don't forget about that x on the outside. That's going to be a 0, and then we have negative 1, and then we have positive 3. And since it's a disco, we know that it's going to be going down as we go to the left, and then it's going up as we go to the right. Okay, and our y-intercept is 0. So looking at the graph, we see that it comes up, it passes through the negative 1, passes through 0, and then passes through that positive 3. And then all I did is just split the difference. And now you're not going to get something like this, because if you split the difference between 1 and 3, you would do 1.5. So notice that it's so close. Like, I'm cool with that. Okay, like we could get super exact, but I think you'll get exact like that in calculus. But if you put a point right here, I'm okay with that. And then right here, this one's pretty good. I mean, it's not exactly at 1/2. It's at 0.535, you know. But I mean, you would be really close if you put the point right there. Okay. So hopefully you guys did well. Don't forget to do your homework. Just look at your stamp sheet to figure that out. Actually, I'll pull it up for you. Answer these questions down here, questions number 7 and 8. And then stamp sheet, I want you guys to complete, we did page 30. Oh, no, we haven't done, we did page 28 and 29. Do page 30 and then also page 31 for homework tonight. All right, we'll see you next time.